So simply, when we have our profit function, when we maximize this profit, then by maximizing this profit, we will get some function of x, some value of x, not function, some value of x, which this x is a function of output price and as a function of input prices, which this one called input demand function, but unconditional input demand function. Why unconditional? Because in this input demand function, we do not have any quantity, any output. This x is just a function of prices and wages. Function of prices. Both of them is price. This is price of output, this is price of input. So it's not a function of output. So when your input demand function is not a function of output, it's called unconditional factor demand. Instead of factor, we can write input. Any of them is fine. Unconditional input demand function or unconditional factor demand function. And also, when we get, by maximizing our profit, when we get our unconditional factor demand function, then by substituting this unconditional factor demand function to our production function, we will get our supply function as a function of output prices and input prices. Because we have, like, our function is y is a function of f of x. Yeah? Y is a function of x. But now, x itself is a function of P and W. Then we can write down f of x as a function of P and W. Then finally, f is a function of P and W, or y is a function of P and W. And instead of this one, we can write down y as a function of P and W. So this is our supply function. And this is the unconditional factor demand function. Unconditional factor demand function, which is not conditioned on our output. Unconditional factor demand function. Again, why is it unconditional? Because we do not have any quantity. It's not conditioned on quantity. Although if you remember, we told that in case of perfect competitive, the price is already given. We need to maximize our profit based on the level of output. But here we don't have anything about Q or output. It's just a function of P and W. It's a function of P and W. So there are some properties for the unconditional factor demand function. The first one, non-positive on factor demand price effect, which is as both of them less than 0. What does it mean? It means when the price of input 1 increase, the demand for input 1 would decrease. Would decrease. And when the price of input 2 increase, the demand for input 2 decrease. That's why when we, for example, when we are going to the second order condition, so it should be less than 0. The partial derivative of x1 with respect to w1 should be less than and equal to 0. It means when the price of input 1 increase, the demand should be either will be no change or should reduce. It should not increase. When the price increases, you use more than, right? And also, another way, when the price of input 2 increase, what will happen to the demand for input 1 is exactly the same when the price of input 1 increase, then what will happen to the input 2? It's a kind of cross partial derivative. As you know already, when we are getting the first order condition, when we move to the second order condition, with second order condition we are getting the cross partial derivative, so we will have this kind of condition. As you know, in consumer theory also, specifically in the Hicksian demand function, the cross partial derivative was identical. The cross partial derivative was identical. Here is also, when the price of input 2 increase, the effect of that one to the demand on input 1 is equal to when the price of input 1 increase and its effect to input 2. If we have complement input, which we need to use both of them, and the complement input, when the price of output 2 increase, the demand for output 1 would decrease. Why? Because they're complement. And also, when the price of output 1 increase, the demand for input 2 also would decrease. Because they are perfect complement. That means when, for example, as we know already here, when the price of W1 increase, so the demand for X1 decrease. As also X1 is a complement with X2, so now also we use less X2 because they are complement. We cannot use them as in isolation, just separately. We have to use them together. But when it comes to substitute, in the substitute the case is different. When the price of input 2 increase, the demand for input 1 increase. Why? Because they are substitute. Now, instead of input 2, we can use more input 1 to produce the same level of output. And when the price of input 1 increase, now we use more amount of X2. And instead of X1, we use more X2. So then the demand for X2 would increase. And also, the next properties for unconditional factor demand function is this one, which is positive output price effect. What does it mean? If the price of output increase, the demand for input increase. Why? What do you think? When the price of output increase, the demand for input increase. It's very simple. When the price of output in the market, so what is the relationship between price and supply?
The price increase, then the supply
increase. So when the price increase, as a result, supply should increase.
If the price of the output increase, we need more output. Then we need more X1.
Yeah. So in order to supply more, you need more X1, more input. Not only X1, you need more X1 and X2. Because in order to increase your supply, you need more input. So that's why when the price of output increase, the demand for input increase. Why? Because you need to increase your supply. For increasing your supply, you need to produce more. For producing more, you need to have more input. This is the logic. So, and also we have some properties for our supply function, which is this one, y of PW, which is equal to f of x PW. That means once we have our input, unconditional input demand function, we can find out our supply function, which is this one. It has two simple properties. The first one, on price effect is non-negative. What does it mean? when the price of output increase, you supply more. It was already talking before. When the price of output increase, because now you can get more profit from the market, you are willing to sell more. When you are willing to sell more, you need to supply more. Then your supply should increase. As we already know that the relation between price and supply is like this. P increase, then supply should increase. That's from the basic supply law. As P increase, the supply should increase. So that's why the partial derivative of output with respect to output price should be greater than or equal to 0. It means it should not be negative. And sometimes there's no change, but then sometimes there is a positive change. And also we have this symmetry here. When the price of output increase, what will happen to the price of input is equal to, with having minus sign, is equal to when the price of input increase, what will happen to the output. As we already know, when the price of input increase, the supply or the output will reduce, because now the output cost will increase. When the output cost increase, we are trying to produce less in order to reduce the cost. And it's equal to completely when the price of output increase, what will happen to input? As we already said, when the price of output increase, the demand for input increase. But here, we multiply the minus sign in order to equalize both sides of the equation. So this is the two properties for the supply function that we have here. So another properties that will work for both supply function and factor demand function is this one. Both the unconditional factor demand function and supply function are homogeneous of degree 0, HD 0. So for the proof, suppose we have this profit maximization problem. If we multiply both output price and input price by some amount of T, multiply the P, so here it's similar. This is Fx or your Q. This is P multiplied by T. This is your cost. So let me write down specifically. This is our revenue. This is our cost. So our profit is revenue minus cost. So it says it's homogeneous of degree 0, especially in the input and output factor prices. So T multiplied by P multiplied by f of x minus T multiplied by W is equal to x. So now, it's straightforward. We have TP multiplied by f of x minus TW multiplied by x is equal to T multiplied by TF of x minus T multiplied by WX. And we have T as a common factor, then T multiplied by PF of x minus WX. And we know that the P multiplied by f of x minus WX is this profit function. Then T multiplied by pi, or profit. And we, from the homogeneous of degree, we know that if we have f of tx is equal to t multiplied to the power of k multiplied to the f of x, this function is homogeneous of degree k. But in this case, our k here is equal to 0. Then when k is equal to 0, then this is homogeneous of degree how much? As I said, when we have f of tx, then it's equal to t multiplied by k multiplied by f of x, then it's homogeneous of degree k. As value we have as a k is homogeneous of degree k. But here k is equal to 0. Then it should be homogeneous of degree k 0. No, I said it's homogeneous of degree k, but now k is 0. When k is 1, it's homogeneous of degree 1. But now k is 0. It's homogeneous of degree 0. K is 0. When k is 2, it's homogeneous of degree 2. When k is 1, it's homogeneous of degree 1. When k is 10, it's homogeneous of degree 10. When k is 0, it's homogeneous of degree 0. And also, by having this profit function, we find out that both the factor demand function and also the supply function, they can be homogeneous of degree 0. Why? They are homogeneous of degree 0 because our profit is homogeneous of degree 0. We derive them from our profit function. And also in another way, we have two ways of proving this one. If, for example, this is our supply function, which is simply y as a function of p and w. So now suppose we scale up p and w both by some amount of t. Then this supply function will change to this one, y of t multiplied by p, t multiplied by w. T multiplied by w. And also, this supply function comes from this demand function, which is Tp multiplied by Tw. And also, again, when we solve for the supply function and demand function, when we multiply price and W by some scalar of T, again, we have exactly the same thing. So the initial supply function is exactly as the supply function after scaling. What do you think why? I mean, when both the input price and the output price, they increase with the same level, what change will happen to your supply and demand for input? Both of them increasing the same level.
The output doesn't change.
We already learned that when the input price increase, when the input price increase, the supply decrease. Yeah? When the input price increase, because now it's more costly, we reduce the supply. But when the output price increase, the supply increase. The supply increase. The other way around. So let me tell you by example. Suppose that this is our output. Y is our output. Yeah? We have two things that affect this Y. It's own output price and input price. And input price. So now, suppose that the P increased by 2. Then the supply increased by the similar amount. Suppose it's also increased by the similar amount, by 2. Because the price increased, now we have more profit, we supply more. But suppose this one, our W increased by 2. Then we supply less, supply reduced. Suppose this one is also reduced by 2. So this increase with this decrease will get the result of 0. So that's why when you multiply both Y and T with some same amount, which is, for example, here is 2, Here you bring some positive 2, but here you bring some negative 2. So the final result will be what? No change. So that's why this new supply is equal to exactly the previous supply, because both price is changing at the same value.
Too unique.
Yeah, it's too unique, but it's just like a properties in case if they change at the same amount.